Hello and welcome to yet another episode of Guess What? Not C++ Fast Track for game developers who want to do game programming stuff and do other stuff good too. This is another completely different subject, like Monty
It's
Python
C++
said.
slow track because we have time now.
That's right. Now we can go slow-mo, we can review everything, answer questions, not just blast through reviewing intake assignments. But anyways, why did I do that? I actually ended up closing the window, or I had already prepared most of the stuff. But let me just share my screen here. Let me just bring up the CMake page. CMake. All right, so as the title of the lecture states, let's make sure I share the right screen. Now I'm going to start sharing the screen. I'm going to move my mouse into OBS Studio. Look, everything looks fine in OBS. Who knows what's going to happen in the recording, but okay, we'll see. Once I start streaming in Discord, it's going to be like, 5 frames per second. If you're lucky, maybe 1 frame every 5 seconds. Okay, yeah. So CMake. So CMake. So there was a few questions in the server about, working with CMake or working with CMake projects or even making your own CMake project or, working with CMake. So in this video, I'm just gonna just show you a few things. First of all, what is CMake? Well, yeah, I guess most of you kind of know that. And we'll also work with a CMake project, which that somebody maybe has had issues with, and then we'll just make a little CMake project on our own from scratch. At least I'm going to try that. I did not practice anything, so be warned. This is totally ad hoc. I just kind of thought about what I was going to do. I didn't actually prepare anything. So first of all, any questions please not related to the intake, because we're working on it, and you'll know when you know. That's the answer to that question. But anything about CMake or there was this one project I really had trouble with, or anything.
Well, Luke had some questions, I think, with his sprite stuff.
With the sprite stuff?
Programming channel.
Oh, well, I fixed it this
okay.
afternoon.
Okay. All right. Anyways, yeah, so if I look in the programming channel, I don't have time to keep up with the chatter in the programming channel most of the time. So
read that, please.
I think there was some stuff from Benny Bonnell about Rust, I think it is. I don't even know. I can't even, whatever. I'm going to look at that. But, okay, Luke, so you fixed your problem with the sprite rendering?
Yeah, I just got rid of the vector, and then it was a lot easier.
All right. Yeah, so there's a lot of stuff that happens while I'm busy at work, and I just don't pay attention all the time to the chat. So, all right, I'm glad you got it fixed. Anyone else?
No. How do I make Unreal not crash the graphics driver, please?
I got an answer to that one. Don't use Unreal. The the fastest code is the code that doesn't run.
Yeah.
I'll tell you that right now. The perfect
just write
crime
a program in Unreal that when you start it, it just deletes Unreal.
Yes, delete your entire
self-destruct.
Any folder that has Unreal or any hard drive. But anyways, yes, the perfect crime is the one that's never committed. The fastest code is the code that doesn't run. And if you don't use Unreal, you'll never have any problems with Unreal.
Yep.
Lessons to live by.
If only that was an option.
You poor fool. Anyways, all right, so let's get started with CMake. So yeah, CMake is, of course, a cross-platform tool for creating the build files. It's not in itself a build toolchain, but what it does is allows you to describe your project in a build agnostic way. So you're not targeting particular. Well, sometimes you have to, but it's not for Visual Studio, or it's not for C Lion, or it's not for what's that one on the Mac? I can't remember. But anyways, it's targeting many platforms. And although some people are like, oh, it's so terrible. Yeah, because you haven't used it before. And if you haven't used it before, everything is hard to understand at first. And granted, I'm still like with C++ as well. I'm still learning new things every day, and I'm learning new things with every CMake project I also make. And I changed my mind a lot. And I'm like, oh man, that was that wasn't a good way of doing that. And then you find a new and better way of doing things in CMake. And it's always a learning process. But when I was initially writing articles on 3dgap.com, I would always provide the source code for the projects that I was working on. And I would usually just zip them up with a Visual Studio 2005 or 2009 or whatever version of Visual Studio at the time I was using, zip it up, and then put it up on the website. Well, the first articles on 3dgap.com were written, I wouldn't say before CMake was a thing, but definitely before I knew about CMake, but definitely way before GitHub was a thing. I think GitHub's only been around for like maybe 10 years, and I've been writing articles on the website for at least 12, 13 years. I think when I started it was like, I don't know, 2008 or something like that. So I didn't really have all these tools. But what happens is your code goes into what's called code rot, right? It stops working. You can't compile it anymore. The standard template library changes and things break, and it's so annoying. And the Visual Studio projects that you used back then are no longer working now. And if they get upgraded, well, there's always issues. So when I started seeing more and more projects, more open source projects using CMake, I thought, well, this makes sense. Even if I'm just targeting one platform, it makes sense to describe your project in a way that can be regenerated instead of constantly have to maintain the Visual Studio solution and project files. So I right away kind of switched to, right away, about 5-10 years later, I switched to CMake for all the projects, even if they were just for, targeting Visual Studio, even my DirectX projects, because having to when Windows 10 came out, also Visual Studio, you had this Windows 10 SDKs that you had to keep installing, and you still do. Windows 11 SDKs, Windows 10, the numbering hasn't really changed much, but the Windows version that the targeting has. But you have to keep updating that constantly. But with CMake, you don't. You just regenerate the project and solution files, and it just works in the most recent version of Visual Studio. So that's why I started using CMake on all the projects. So if you go to 3dgap.com, some of the more recent projects will A, be hosted on GitHub, and B, have CMake files so that you can regenerate the project files. So first step, getting CMake. Obviously, we can go to cmake.org. I hope you guys can see this in the stream as well. Click on download latest release over here. You don't need to fill in any of this crap to stay updated. And we don't want the source files. We don't want to build a build system, right? So we have the installer right down here. Windows 3.2623. I'm going to actually install this because I don't know what version I have, but I might be a few versions behind, so it's good to do an update. And I think in a few seconds it will launch somewhere. Because I'm still in Chrome. I was like, why did it go down here? In Edge, the downloads come up here, and I use Edge for work-related things mostly. Come on, launch.
It's still saving.
Yeah. It's verifying. Doing some kind of virus scan on it or something like this. 32,000 cores, and you still have to wait like half an hour to launch something. All right, so I usually don't computing space requirements. I usually don't change any settings while I'm installing. I just go next, accept license agreement, next, add to path. Yeah, so this is you really want to make sure that you can launch CMake from.
We can see the thing you're sharing your window, your browser.
Oh, that's weird. I thought I was sharing my whole screen, but okay, hold on. Let me just change my stream. I don't know if I had to do that. I probably could have changed it another way. Screen. All right, okay. Screen 3. Yeah, here we go. All right, now we'll see my recorded frames drop. Okay, now I'm sharing the whole screen. All right, anyways, I hope this doesn't break. If I move the window, OBS still looks like it's capturing full frame rate. All right, so anyways, you want to add it to the path because you want to be able to execute it from the command line without having to specify a full path to CMake, obviously. So to do that, it has to add the path to the CMake binary file to the path environment variable. So for all users, for current user, you don't require admin privileges, but for all users, you do require admin privileges to do that. So let's just do for current user. click Next, C drive program file CMake, and install, which should pop up with also with an access control dingus, which it's not doing. Oh, there it is. Barring. All right. And once again, computing space requirements. Yeah, CMake. All right. So that'll install in a few seconds. I hope. 3, 2, 1. Oh, I'm validating. All right, gives me time to take a sip of my drink. Removing shortcuts. This should take a while. Modern hardware. It takes a long time to remove shortcuts. Removing 1 file and 9 directories? That's weird. Okay. I have no idea what these 1 and 9 means.
It's the previous installation, probably.
Or maybe. Maybe, who knows? Okay. Well, yeah.
Casually removing the backup, okay.
Yeah. All right. So, that was installing CMake. I mean, that's the easy part, right? So CMake comes with CMake GUI. I'll just show you what this looks like. I currently have it on the wrong window, but okay. So here's another project that I'm working on. It's a CMake project in the Software Authorizer. And when I just open it, okay, it found this path that I was previously working on. And it gives me a list of, variables, basically, options or whatever. They're called options in the CMake files, but okay. Configuration options. So SR is the Software Rasterizer namespace, kind of. You should prepend your namespace name so you can group them up and they don't get mixed up with other variables. If you don't group them, they just look like this, so that's not pretty, and usually you just want to ignore most of them. This project also works on has a dependency on some other third-party libraries, so those CMake variables will show up there as well. For this one, I just want to make sure the samples are built. Now, everything shows up red initially because they are not cached, meaning you can change them, or there's a cache file behind the scenes. You can delete that cache file, and that will allow you to regenerate the file completely, which is super useful for development. But for most cases, you just want to select or just keep everything as default and just click on Configure. Now, if you click on Configure and everything goes all right, no errors occur, then these red options should go white. We'll see in a second here. Okay, so they go white. So white means that everything was fine, and now with the current configuration, now anytime you hit configure, you can do this a couple times, okay, without breaking anything. So hitting configure too many times doesn't break anything. Yeah, if I hit it twice, it might break something. But yeah, you can also do things like fetch things. So what it's doing here, it's fetching the audio library from GitHub. It's fetching another library called GLM, FMT. These things are being fetched directly from GitHub. But if you configure them correctly, it shouldn't fetch from GitHub because the tags match. So then you just get the same version. But anyway, so now it's all white, and now we can click on Generate. And that will generate the current generator is Visual Studio 2022. And then I click the Generate button, and then I can just click Open, and it should magically open that project in Visual Studio, which apparently...
So probably worth noting, when you first add the path to where the project is located, you need to click Configure as well to have the variable show up.
Yeah, so we'll just, if I just go delete cache first, are you sure? Yeah, I delete. So this is what it looks like initially, just an empty list. So if you only select the source path, and you also have to select where the builds are. But we'll look at that in a second. I don't want to look at that too much in detail right now, but just click Configure. It'll say, what version do you want to target? So these are all the possible generators that you can use. Well, we only care about Visual Studio 17, which was the default here, so thank you. Usually you can just go with the default. Use default native compilers. These options are for doing cross toolchain. So, for example, you might be on Windows and actually compiling for Linux. That's totally possible. Or compiling for PlayStation or whatever, different consoles. But for this, it's just native because we're just using the native toolset for Windows on Windows. All right, then I'll do this again. So nothing should change because I haven't really changed any of the variables. Everything should still be default. So now it found and it parses the file, finds the variables. We hit configure again. Everything goes white. And then he's like, fine, we can generate our file now. So we generate that, and then we launch it, and this is the Visual Studio project that gets generated from that. All right, so that was the quick overview of using CMake. Now, does anybody have like, oh, I tried to use, I wanted to use this project. How can I build this project using CMake, or just like off-the-shelf GitHub repo or something like that they want to go over? No? Any particular project or library that had trouble building? All right, well, there's a few projects, and just, off the top of my head, I'm thinking, well, I kind of wanted a physics library. So what was it, Bullet? What was it, Box2D?
Yeah, please don't do bullet physics, God.
Yeah, I'm not sure that might give me some problems. All right, so here's Box2D. I think this is the official Box2D engine. And here, like random something, I was thinking physics. Okay, CMake, obviously, it's got a CMake list file. So if you see CMake list file in the repo, you know that this can be built using CMake. So let's clone this one. I can also download the zip, but I'd rather clone it. I do this a little bit off screen here in my projects folder. So I'm going to put that there and clone Box2D. Let's go. Hopefully there's some samples in here so we can actually see it working. All right, I've got Box2D, and I'm going to open CMake GUI again. And then go browse, and then we'll go back to projects, and now Box2D. There it is. Now I just need to give it the root folder where that CMake list file exists, and that's usually just the root of the Git repo as well. So we select that. That's for the source code. Now the build, you should never use the exact same folder as where the source files are located. So here we go back again to Box2D. What I usually do is you don't have to. It can be literally anywhere on your file system, and there's like a gotcha about that one later. But now I'll just create a folder called build inside the source tree, but it's not in the source tree itself, and this is where I'll make the build files. And then I'll hit configure. Yeah, default toolchain 2022. Thank you very much. Windows 4 Windows, on Windows 4 Windows. And it does the same thing. As you can see, there's a few less options because this is just a library, not a whole engine or something like that. So there's a few options here. Build docs, test bed. I don't think we want that. I don't think we want. We don't want the unit tests either. User settings. I'm not exactly sure. Sometimes if you mouse over on them, you can see. Override Box2D settings with B2 user settings.h. No, I haven't done that, so I'm not going to click that one. I don't see any option for like examples. Maybe something under ungroup. Build shared libs.
Testbed is examples.
Oh, is it? Okay, let's leave that one on then. This is like jumping. Let's shrink that down. All right, and then yeah, that's it, right? So I don't need unit tests. I definitely don't want to build docs from this because that's annoying. Configuration types, these are basically default from CMake. They always get debug, release, min-size, release with debug info, but you can delete these ones if you just want, for example, if you want debug and release only, you don't care about these, I just leave this on. It's like, whatever.
Are those like configurations that are like defined in CMake?
Yes.
Or do you make, because like,
yeah, but there's
just adding them will like configure them correctly, is that?
Yeah, adding another one called hubadapub probably will generate an error.
Okay.
I mean, we can try like blah, and then if I hit configure, he's probably going to go like blah, unknown configuration type. So it's got to be one of these four. I mean, I've never tried this, honestly, ever. Why would you create a new configuration type? I don't know. Most of the configuration that you can specify in the CMake list file will be based on one of these types: debug, release, min-size release, or release with debug info. And so it doesn't really know anything about any other configuration type. So just adding one on here, I'm pretty sure this should generate an error, but let's try. Let's just hit configure. It says it's done. Okay, so it said configure done. So
on the tooltip, it said all other will be ignored.
Oh, okay.
No.
Anything else will be ignored. Okay, good. Good.
Yeah.
There we have the information right there. It says semicolon list, but yeah, are those semicolons? Yeah, they are. Okay, I guess they are semicolons. But okay, blah is ignored, and it will just use these configurations. But you can remove them. Okay, but you can't we cannot add new ones. So let's just remove these two, just for shits and giggles. But I never delete them. I just leave them as the default. It's really
kind of weird way of doing that then, I guess. If you can only have 4 options.
Yeah, I suppose. The install prefix is also something that you see often, and there, in addition to building, you can also install a library, and then the install files will go into a folder here. On Windows, I never use this, but on Linux, it might be useful because usually the header files and libraries are put in some system location so that your projects can link against them and include in a more standard way. But honestly, I never touched the install prefix. I've only recently even tried to configure a project with an install option. But yeah, I ignore that. But what do we have in here? Oh yeah, shared libs. That's also another one. So CMake allows you to quickly switch between static linking and dynamic linking libraries. So you can create a DLL generally just by, depending on how the configuration is, just by ticking this box, and then your projects will be configured to be DLLs instead of static linking. It's not something that just works out of the box. You got to do some configuration for that to work properly. So I would just not check that box on your own projects unless you know what you're doing. But just leave build shared libs unchecked, and it will give you static libs. All right, we did make a few changes, so let's just configure again. Everything's white and generate, and now we're going to open Box 2D. So 1, 2, 3. Interesting. Okay, hold on. We see quite a few projects here. So it looks like we have ImGUI also part of this GitHub repo.
Yeah, it's for the testbed.
For the testbed, I guess.
Yeah.
And Box 2D, I'm guessing, is just going to be, whoa, that's a lot of options here. Static library, right? So you guys can see that, okay?
Yep.
I hope. Yeah, so if we build this, it will generate a static lib. So let's do that.
It's going to build a testbed.
Yeah. Well, it's going to build the whole thing, right? Testbed has a dependency on, should have a dependency on, sorry. References. Yeah, so Box2D will be compiled as well. I mean, it won't only compile this one, it will compile everything that's dependent on. And Control-Shift-B is the same as right-clicking on this and saying build solution, right? So it'll build the whole solution. All right, so with that, it is already set as the default, so we can set it as the startup project. No, not configure startup project, but anyways, if we hit F5, if nothing breaks, we should get a Box2D testbed with an ImGUI window and everything in it. Oh, sweet. Look at that. It just works. All right. And as a result, I don't know how to control this thing. Okay, apparently I can rotate the window and stuff.
Yeah, there's like settings somewhere.
Oh, I can scroll. Cool. All right, so there you go. 2D physics. Amazing. It works. What is this junk? Wow, I didn't realize this was actually junk from Box2D. Oh, that's good to know. So I guess there's some students who are actually building their projects on the testbed, because I saw this before, this junk in the debug output. Now I know what it is. They're just copying the testbed. All right. But okay. But really all we want is the library. So if we want to find out where that actually went to, we can look at the properties. Now you'll notice too that it's using absolute paths for everything. See, I got my Box2D project in D drive projects, Box2D. Right, so because these things are being configured with absolute paths, you cannot distribute the solution file or the project files that are generated from CMake. You should only distribute the CMake files themselves and let everyone else generate them the exact same way I just did by using CMake GUI and generate the project files themselves. Don't, please, for the love of all things good and holy, do not distribute the project files generated from a CMake project without heavily editing them. I can show you another example. If I go to, I think if I unload, I can unload a project. Let's see, where's that option to unload? Here it is, unload project. And then with it unloaded, I can actually edit it in here. I think, yeah, look, Look. These are all the compiled files here. So it's going to use absolute paths for absolutely everything. All the files in your project are all using absolute paths. So you just cannot distribute these files unless you heavily edit them. Let's reload
option.
project. Yeah, there we go. Okay, back to normal here. But that's it basically. You load it up into CMake GUI root folder. You select a build location, and you press go. Now, what happens on the actual? Let's see if I can. I don't want to show.
So I do have like one question about
Yeah.
this, I guess, because I notice a lot with a lot of the projects that you make with CMake. It has like a 0 build project. What's that?
That is an excellent question. So most of the time, I turn on solution folders, and then I think Box2D does this as well, and then I just hide them. This one, all I know is the all build. This one has the CMake list in the root folder. So if I want to get to the CMake list in the root folder, so this one could be CMake list in a source folder somewhere else, right? So this is from extern mgui. So this one is not the same as the one that you get in the root folder. So anytime you build a target, like for example testbed, it will attach the CMake list file for that project. But to get to the one at the root level, you got to go to all build. Install is what it sounds like. Like I said, it's got an install location. So if I actually build this one, it would end up installing the project into the folders. Zero check, I think it's just used to check whether the file has been changed. And if it has, then it's going to regenerate the project file. So I want to show you something else in my other project, not this one, but I'll show you something else about workflow with CMake projects that personally is my preferred way of working. But I think that's what it's doing. It just has like one dependency file or something in it, which the date stamp, the timestamp on this file is checked against the timestamp of the CMake list file and whether or not it should be regenerated to regenerate the projects and solution files. Does that make sense?
I guess.
Yeah, I don't know. It's
just don't worry about it. That's what I get.
Yeah, if you look at this one, it has a custom build file on it, like a build tool on it, custom steps, whatever, and it will basically use the timestamp file just to check to see if CMake files need to be regenerated, something like that. So ignore. It just makes your life easier. That's what it does. But you don't need it. I mean, you shouldn't delete it because that will probably, break some workflows, which I'll describe later. Okay. Right. So we should have debug release. Yeah, because we deleted the other two configurations, min size release and release with debug information. We should also get a release build. All right. I also want to show you where they end up going. So obviously we can see, if we just build this one, we can see mgui.lib. Here we go. So it's being output to a bin folder in the build directory. So the build directory is where we told Box2D to output. Let's see if I can make this a bit bigger here. All right, so here's our build directory and bin. So for release builds, this is where the libraries go, and apparently the executable and debug builds go here. In this case, they actually added a D. So if you wanted to put them into another one folder back, they wouldn't conflict. But yeah, you need the library files to link against them. So if you in your own project, you can copy the libs that are generated from the build and the header files. Now, do be aware that library files compiled with Visual Studio 2022 don't necessarily work with earlier versions of Visual Studio, even Visual Studio 2022. As Stamper has shown, newer versions of Visual Studio
mostly, I think,
break binary compatibility with even your earlier versions of Visual Studio. Yeah, so sorry, Alex, that freaked you out for a while when when Lynn couldn't compile your project, well, more specifically, couldn't link it, I guess. Yeah, I didn't say don't distribute the libs. I should have said that, and it gave us awareness of this possible issue, so that was nice, but at the same time, lib files are not to be distributed necessarily. But okay, that being said, the third part. At this point, any questions about using CMake in your own projects? Okay. Yeah, so generally you don't mix and match, right? So if you're like, okay, but I'm using Visual Studio for my other project and I want to integrate this library, for example, Box Studio, I want to integrate that into my own project. You don't just drop the CMake list file in there and say, okay, let's go. Because like I said, those project files that get generated, you cannot distribute. You couldn't even take this generated project file and add it into your solution because the files are all using absolute paths. So the best thing to do is what I just said. Find the binary file wherever it went. Rats, I closed the window. The drive projects. I think it was here. Let's just go here. Find the actual generated files. This is the build, the binary files that you need. So this is the debug lib, release lib, and not the source files, because once you've compiled your lib files, you don't need source files anymore. Oh, crap. Why did it go back? Open file location. So what we need is the lib files and the include. Here they are, which is in a subfolder called Box Studio. So that's what you need. You need the library files and you need the include files. And that's it. You copy those over into your project's external directories or wherever, and that should be enough. You point your linker settings at the library files, you point your compiler settings at the include files, and it should be good enough. Right? So that's how you would work with a CMake project in a Visual Studio project. Now, of course, if you want to, you can, for example, take the source files and you can literally just copy them all to another project. And then you can compile the code directly. But for projects with hundreds of source files, that's going to get pretty messy. And although there might not be any particularly fancy settings on any of these files, it should be enough to just copy and paste them in. But here you see heavy header files in here. They're probably in the source folder because they're internal. They're not meant to be distributed. And then it just really makes your project really nasty. So I wouldn't go that route. I would just say here, point at the include files, link against the static linked libraries that were built in the build file, and be done with it. And just put a disclaimer on your project that says, hey, this project works with Visual Studio 2022. Now, if you're using CMake for your project, well, that's different because then you can just pull in the CMake project from GitHub and use it. Now we can switch gears and let's set up a little dummy project called, I don't know, using CMake. Like this. And then, the first thing, of course, for every CMake project is CMake lists. CMake lists, .txt, yeah. Right, so here's our root folder for our CMake project. Let's open this up. I'm going to use this. I'm not going to use this. Right, so here's our CMake project. I'm going to use a example, which I already have on my other screen here. Let's use the audio library just as a basis for what I can work with here. All right. So what you'll notice at the top is a CMake minimum required. Now this always has to be at the top of the list. Now, usually what you can do is you can just say, okay, what version am I using? 3.26.3? 3.26.3, but this is the version that you have, but it may not necessarily be the version that whatever build toolchain, whatever version of CMake that your end users are going to be using. So my advice is to basically use the minimum version that you really need. And now how do you know that one? Well, okay, we can go to CMake and we can look through the history to find out what's what. Here we got resources, documentation. Open that up in a new tab, online documentation. Yep. All right. So we can go through different versions here and find out if the commands that you want to use are going to be there, right? So, but I can tell you right now, 3.2 or maybe even 3.22 will be pretty widely accepted. So 3.22.6, let's go with that. 226. I mean, like, how do you know? How do you know when to bump the CMake required version? Well, just test it on the platforms that you want to use it on. For example, I was using a Linux to build one of the projects. I was trying to build the audio library. The audio library worked fine on Linux, by the way. But on another project I was working on, I had to reduce the CMake minimum required to get it to work on Linux, because Linux didn't have the latest version of CMake on it. It takes a while before it will distribute. So I actually had to downgrade it to. I didn't have to change anything. I just had to change the minimum required version to something like 3.22.3 or something like that. I don't know what. All right. Anyways, we need this command here. Otherwise, CMake doesn't know how to set up rules and stuff for parsing the file. All right, we have that. And then second thing we need, we don't need any options, but we do need to specify the project. So let's put that in there, because this tells CMake what we're doing, and specifically the languages. It starts setting it up with some global variables that will be available to your project for CMake. And we're going to call this using CMake. I don't know, something. This is going to be the solution name in Visual Studio when you configure this. All right. Hold on. Let me just move that there for a second. That wasn't the one I wanted. I'm clicking the wrong boxes here again, as usual. Yeah. Okay. As I figured, it's just showing every single folder I have on my computer, but whatever. I don't necessarily want to have everything streamed to the internet. But let's create a new file here. Let's just call it main.cpp, because we need to have at least a main file. I won't fill it in. I just need to have a file there so I can actually put it in there. And we're going to make, initially we're going to make an executable. So when we make an executable, we have to specify the add executable. Let's see if I have it here. No, I don't. It's in this example. So what I can, let me just, because I don't memorize the syntax of all these commands. So we check CMake documentation. All right, so that's the name of the project that we want. If we want a Win32 entry point, okay, it's not going to be Mac OS X bundle. And then the source files are listed, or a variable which points to source files. All right, so let's just copy that. Go back here. And we're going to make an executable called, I don't know, hello world, something, right? And main.cpp, because we only have one source file. Currently, we only have one source file. Okay. So now we do have this file existing, so we can at least generate this. We're just going to, I don't know, I'm not going to fill it in yet. It doesn't actually have to contain code for CMake to generate the solution and project files with it. So this is really a minimum CMake file I have right here. Let's just make sure that I copy full paths, I guess, to clipboard. And let's switch over to this one. Get rid of that. And then we're going to also change the build directory to using CMake. Where was it? Using CMake or learning CMake? Using CMake. And then we're going to create a new folder called build, where we'll keep our build generated files. Let's configure that. Native. Yeah. All right, then it goes and says, okay, yeah, I found compiler. Here's our compiler, or we found a C compiler, found a CXX compiler, or a C++ compiler. You'll notice that the same file on Visual Studio, but they can be different. All right, so we get these two things, install prefix and configuration types. I'm just going to leave them as default. Hit configure again. Everything goes white. We're good. Now we generate and just click open project. And lo and behold, we have our project with hello world with a single source file from main.cpp, which is empty because we haven't filled it in. So let's fill it in, hash include IOStream, just to make sure that everything is set up correctly. Wait for resharper. And the minimal main entry point. And compile. And it worked. It generated an executable. So it generates configurations for all these different types, usually just x64 because we don't care about Windows 32 anymore. But this is something that we can start working with right out of the box. All right, so that was an executable. We might actually also, let's see how we would create. Let's create a new folder called library. I don't know. Let's see how we set up a library. We'll just create a new file here called calculator.cpp. And we'll leave it blank for now, because I just want to see how we can set up a library. So add library, and there's some IntelliSense here, but we give it a name, calculator, and we give it a CPP file called library. Actually, you know what I'm going to do? I'm going to make another CMake list file here inside my library folder, because we want to make a reusable library that we can, use on other projects. So here it is, and instead of using add library, I'm going to copy these lines out, and then I'm going to put them over here because we need this as well. Every CMake list file should have this at the very first line. And now we're going to call this project calculator, and although I'm using this inside of another project, calculator. It doesn't matter because if I use this as a standalone project, it will pick this up as calculator. If I use it inside this, the project will be this one. And then I can, like a header file, I can include this one. I want to say add library, calculator, and then the calculator.cpp. And that's basically it. There is something else about libraries, though. Remember I told you about that build shared libs variable? Although we don't see it here. It could be that somebody enables it. And if we haven't set up a project to be a shared library, we should definitely mark this as static. So this makes this library always generate a static library instead of a dynamic library. Because, we haven't set up a project to be a dynamic library, so we shouldn't allow it. And now, in the main one, we can just I can't remember, was it add directory? No, I don't think it was add directory. I think it was include directories. Not include directories. Oh my gosh. It was, where was it? That library. This is for, where was that example? I'm just scrolling right past it. I know I scrolled past it. Here it was. Add subdirectory. That's the one I want. And the add subdirectory just will traverse into the subdirectory called library and look for a CMake list file there. So I put it in a folder called library, and it will look for this file, CMake list, and just include that file there. So add subdirectory. And now I've made changes to the CMake list file. It will be the same one on here, right? And if I hit Control F7, I can compile this file as if it was a source file, hitting Control F7. So, or right click on it and just say compile. And it will do the CMake list thing in here. I don't need to keep going to the GUI. If I want to make changes to this file, I can do this right in Visual Studio. And in fact, I'm going to stop using Notepad. I'm going to do this right here. And it did what I asked it to. It added the library. If I right click on this and I click on properties, you'll see that it set it up as a static library. All right, no configuration necessary. It just kind of works out of the box, I would say, kind of. So now we have the library file. We're going to add a few functions to it. Well, I need a header file, but anyways, let's just use integers for the sake of simplicity. And we'll have add a b. Let's see, CPP file, so we'll implement it here. Return a plus b. And subtract. I know it's a pretty lame library, but whatever. Just for example. And then a minus b. Return a minus b. Okay. And I need a header file. So one way you could actually just right click and say add new file or whatever. But generally I'll just go to the Windows Explorer or whatever like that or whatever and add a new file, calculator.h. Good enough. You can also, I guess you can also click on this button up here in Visual Studio to show all files. And then it should give you, here's the CPP file. I don't know if I right click on this, will I get the, see, this is problematic with CMake projects because although I have the file in the solution, it's in a completely different directory than where the build files are generated. So I'm worried that if I add a new item from here, then it's probably going to put it in the wrong place. So let's call this, well, it's not a file, it's not new actually because it's an existing item because I already created it. So let's do that. Add existing item. See, now it puts me in the build folder. I always have to go back. This is why I usually don't use Visual Studio for this reason. Go into library and then I can find the header file. Yeah, and any file that you want in the solution, .h, is that right? You have to add it to the library. Okay, now it created a header file filter for me and put that there. So calculator.cpp, calculator.h. And we only have the two functions. I'm just gonna copy their signatures. Oh man, come on. Delete that, and then just add semicolons there. So the header file just says that these two functions exist, doesn't tell them necessarily where they are. I'm sure the linker will find out. And that's all I need for my header file. This, for large projects, obviously adding files to the add library or add executable starts to get really messy. So what I do is I create variables for this. So if you have a small project, you can just create a variable called include, or usually you have some kind of like calculate or inc or something like that, where you then start specifying all of your header files there in this variable. So it's a bit of a convention that variables are uppercase. CMake commands are written in lowercase. Any variable you use, like this one, static, well, it's a command, more of a command than a variable, but the variables are uppercase. And we'll do the same for calculator. You don't really have to worry about clashing of names because names are, I think, in this scope, but not in the parent scope. So if I had another variable in the previous CMake list file here where I add subdirectory, then they won't clash. Fairly certain. Calculator.cpp. And then to keep it simple, I just say all files, something like this. And then to use a variable in CMake, you use a $, and then we just kind of append. These will just get expanded to what they contain. So if they have a lot of files in them, they'll just get combined into all files. And then I just take all files here and then just replace that with the variable all files. That keeps it a little bit cleaner.
Can you not just specify a path to like your CPP files if you have that in like a separate single folder?
I do that right here. That's the path to the CPP file. All right, so I'll tell you why I don't do that. It's called a blob. You can do blobbing on folders. But if I do it like this, and then I hit Control F7, it will recognize that the file has changed and it will rebuild it. All right, so if I add a new file, calculator 2, whatever, rebuild it, this will obviously cause an error, but that file doesn't exist. If I remove it, it will detect that it's been modified and will rebuild. If I used blobs, that wouldn't happen, right? It would not detect any new changes. It doesn't do file scans. It only scans to see if the file itself, like the CMake list file, has changed. If it has, it will regenerate the project files for you.
Okay.
Yeah. So even if you do a Control-Shift-B to rebuild everything, it will run the CMake check to make sure that nothing. Look, the first thing it does, zero check. A zero check checks to see if anything has changed. Right. So if you just use blobs, it won't get picked up.
Okay.
So best practice is not to use file blobbing. It does get quite big sometimes, I guess, when you have like large files like this. You get a lot of include files, right? A lot of source files. But really, like if you're adding one file at a time, it's quite doable, I would say. And I mean, the amount of time that you spend configuring projects, really, once you get used to this, it's definitely better. And for blobbing too, it's super hard to filter, right? If you want to say, well, take everything in this file, except for the Win32 builds, except for the Linux, except for oh, god damn it. Then you have to like start filtering in your globular files and globs. I don't know. I think it's called globs. But anyways, yeah. So we've got this library now called Calculator, and we actually want to use it in our Hello World project. So ideally, we should be able to go #include. Well, it's not in the same directory, so we're going to use angle brackets calculator, but it's not finding it, right? So we still have to tell him. We still have to tell CMake where these files are. So to include, for example, to have another include directory on the calculator project, I just give target include directories, and then I specify the name of the target calculator. And then you have a few options here. Public includes are include files that you want to have distributed outside of your project. So in that case, I want to use the ./ which means current directory. So the same directory as the CMake list file, this will be part of the include directories. Now I can also compile that right away. And if I do that, you'll see that in the projects C++ directory, you see right away that the root folder here, again, absolute path, gets added to your include directories. But what's cool is that if I want to use the calculator project in my other project, in the main here, all I have to say is target link, it should be link libraries, not link directories, link libraries, and I want hello world. And again, I have an option here to say public, but this is an executable, so it's kind of like end of the line, doesn't really matter. And I can say calculator, right? So this is a valid target that I can now link. And what happens is that hello world will automatically get the public include folders for the calculator project. I should probably rename that. Shouldn't be a library, should be in calculator. But the point is to configure all the settings, all the necessary build configurations for the calculator project. All I have to say is that here he's got a bunch of include directories. You can do that for some defines as well if you need to define things. And all those settings will be included in any dependent project and will be added as a reference. And the build dependencies will be set up correctly for the projects. Our calculator is a build dependency and zero check. Yeah. So all that stuff is already like pre-configured. And now, if I go to main and I want to include the calculator file now, it should work. Calculator. And now I can just say, I don't know what do you want to say, 4 plus 5 is add 4, 5. Okay, so it found the function, found the header file. If I build this now, it'll link against the calculator library, right? So that's another thing it does for you automatically. It just, sets up your linker for you so that the additional library directories, additional dependencies get linked in. Calculator.lib is being linked in here. For debug, for release, all the different configurations are configured correctly for you. Release with debug information, min size release, whatever. Everything should just work, right? I didn't need to rebuild that one apparently. Wait, I wanted to go to release. Okay, so it just rebuilds everything, puts everything in the right directory, and boom, like it should just work. Okay, but now you're like, oh man, why is it putting it in these folders? I really don't want them in those folders. And this is something that I'm always reconfiguring as well. So for the output, you can change where those files are being output. So here I want to change only the runtime and the library because I'm not using archive. Archive is for DLLs. Oh wait, no, sorry, that's wrong. Archive is actually for static libraries. CMake library output path is for the DLLs, and the runtime output directory is for executable files. So really all I want are the first and the last one here. And I'm going to copy those into my Hello World example. If I'm not mistaken, okay, they can come before project. Some variables have to come after project, and some have to come before, or can come before. In this case, I can set these variables before. And now, with those changes in there, if I rebuild this, so now that you see them here, it should detect that it's changed, and I can just recompile it, and boom, it'll recreate the project for me. Now we should see that the output will go to bin release in the root directory. Okay, so let's do that again. Great. Now it changed an output calculator under lib release and this one under bin release. So before they were in the build directory, now they're at least in my, not that project, using CMake. Bin. So the executable should go here, hello world, and the library files should go here, calculator.lib. This may make it just slightly easier to distribute your project because usually you have like an include folder for your include files, a library folder for your static libraries, and then when you want to distribute your project, you just copy the include and the lib folders, and you're kind of done. Should be. And then, yeah, you can use them in a Visual Studio project or whatever. All right. That's pretty much everything I want to cover. Anyone still alive?
Yes.
Any questions about that?
No.
You're like, yeah, but I've seen some people use the open here, whatever. So what I'll show you also, okay, so let's say we don't have Visual Studio. Let's say we can get rid of these generated folders here. We can get rid of that, get rid of bin, and we can get rid of lib. These were, oh yeah, we didn't have anything in include. Okay, so we just have our library. In fact, I'm going to rename this to calculator actually. Calculator, because that's my calculator library. And if I change that, let me just make sure that I also change calculator for the subdirectory. All right, that's it. That's all I should need to do. But sometimes you see people like, oh, I'm just going to open with code, or I'm going to open with Visual Studio right here. Here's an open with Visual Studio. Now that should be possible. Should be possible. The Visual Studio should recognize CMake list projects. Should start configuring it. Say, hey, yo, this is a CMake project, right? You can do cross-platform development if you want, or you could just, build for Windows, whatever. You see CMake generating the output right away. It should give me some kind of like stuff to debug. All right, it ran right away. I didn't see anything happening, so I'm going to put a what was it? System pause, just to get it to pause before it disappears instantly. So right out of the box, I just open it. It's a CMake project. If everything worked, then it should just run. But any questions, you should be able to select the targets, I think. Right, so this is actually the target, and I don't know, I just kind of found it out. But anyway, so if you're not using Visual Studio at all, you should also be able to, Visual Studio also puts things in an out folder, which we also can delete, ignore. But we can also just use Visual Studio Code, which looks like there's a new version, so I keep getting these version stuff. So anyways, Visual Studio Code detects it's a CMake project and gives me like, okay, these are your options. Okay, let's go with the Visual Studio 2022 release, x64 architecture, so that's called AMD 64. A nice plugin for Visual Studio Code, if you don't have it, is the CMake plugin from Microsoft, I think. I think it's from Microsoft. But as you can see, it has the, it's kind of set up in a way that you can actually just see the projects here, kind of like Visual Studio. Here you have the lib file, so you can build that directly, and it creates the lib in that folder we set, in the lib folder. The executable, okay, we can build that, and we should be able to debug it. Now, I don't use Visual Studio that much, but let's see if it finds... Oh, no, I didn't find it. Okay, so I do need to set up a launch file for this one. But in any case, CMake is really flexible in a way that, you can just configure it once, and it kind of works everywhere. If you had a different build tool chain, or if you were targeting Android, if you were targeting WebGL, or whatever, you barely have to make any changes to your project or to your CMake files if you've set them up correctly. And it will just kind of work for those tool chains. Of course, dependencies aside, you'll have to, download some dependencies and whatnot. But, if you're thinking about doing cross-platform development in the future, and you're like, okay, someday I'm going to make a cross-platform build tool chain. This also works with GitHub Actions. So CMake projects can automatically be configured for targeting or Linux testing, or whatever. Unit testing is also a thing you can do really easily with CMake if you get that far in life. But I don't think I started unit testing until I was, well into my late 30s or something, and only then on a few projects. Okay, any questions?
Do you also know how to build the project from the command line?
No, I don't. Yeah. Let's open a command console here. Nope. Did you know that you can actually type that into the address bar?
Yeah, I always use that.
And that just brings up
so
the command.
Useful.
Right, so, okay, let me just dock that to the right, and we'll dock this one to the left. What did Visual Studio do with it? Okay, I don't know where actually Visual Studio or Visual Studio Code. I'm going to close that, make sure I close that. Oh, that was Box2D and Software Restoration. But I can close those two. I already closed the code project. Let's just get rid of that, just in case that's what Visual Studio generated. Again, oh yeah, build folder. Okay, that's what it did with it. Or was that the folder I generated? Whatever. We can just get rid of anything that's generated. All gone. I found a command in CMake, actually just last week when I was looking into this, to generate the build files using the default build tool chain. See if I can make this bigger. CMake -B build. And what this should do, it should detect your system that you have, and it will generate the build files directly for you. Like, I didn't even specify which generator I wanted to use, but I think you can do that. So, for example, I want to use Visual Studio or Ninja, actually. Let's just say Ninja, because Ninja is a build tool chain as well. Okay, I need to I have to delete the build. Otherwise, it's going to be like, dude, you tried to use this system, now you're trying to use this one. What you doing? All right, so now it's going to use Ninja. Don't know what it actually did, but okay. No, it didn't do anything because it doesn't know which compiler I should be using with Ninja. But all right. Maybe I should have practiced this. But how do you generate the build from? Or you can generate the build, but how do you actually build it from CMake? CMake actually has a build command, but I always have to look it up. because I honestly don't do it this way a lot. But that would be under, let's go back to the root documentation, not commands. Command, yeah, CMake. So build a project, yeah, so you use the minus build. So let's just see if that works. Let's first generate the build, CMake in the build folder. Okay, and let's see if we can get CMake to build it using the build command from the build folder. There we go. Okay, it did it. And it that's the build files. This is the bin file, generates the executable, and it generated the library. Let's see if I can get the release one to build from the command line. But yeah, just go look in the build tool options. I don't know which option I have available here. Generate. There should be a link somewhere. There's probably an option to generate, to make the build for release versions, but I don't know, dude. I don't know. I never use the command line for this unless I'm writing a script and it's a one-time thing I have to do, and then I just never touch it again. But yeah, everything can be done on the command line if you want to automate your build system. There's also like I said, unit testing. You can install your project after build, like copying files to the right directories and things like that to be used on the users and the users and end user system. But yeah, lots of things you can do. Does that answer your question? Was that Luke?
No, it
Max.
was me.
Max, sorry.
Yeah, it does. Thanks.
Okay. Okay. That was it, I guess, for the lesson on CMake. It was 1 hour, so I'm going to end the recording if there's no more questions. I'm not going to end the event. I'm just going to end this to publish it to the webs, and then if you have more questions after that, then we can continue. Okay, thanks for watching.